Is an anonymous function, that is a function without a name, with the ability to refer to identifiers outside its own scope. So let's make a working copy of lambda.cpp, and we'll paste this into our working project here. I'm going to maximize it so you can see the entire file. Up here at the top, we have a class that overrides the function call operator. There on line 11. And on line 14, that function call operator is defined. So this class as a whole is sometimes called a functor because it can be used in place of a callback function, and yet it's more powerful than a function pointer because it allows you to keep some context information, as in the case of this last C character on line 8. And so down here, we're using this functor, here we call it on line 25, as an argument to the transform algorithm from the algorithms library. And you'll notice up there on line 3, we're including algorithm for that purpose, and we're including locale because we use the toUpper function on line 16 and 18. I'll bring this back down to size, and you can see what it does. There on line 23, you see we have a string defined, and it's all lowercase, and so what this does is it simply uppercases the first letter of each word. And so we'll run this. It's a very simple way to do this. And it's a little simplistic, but it works. And there you see big light and sky slated to appear in east in all lowercase letters. And here you have it with initial caps. And so that's being done by that transform function with the fupper callback, which is calling this functor. So for circumstances where you're not going to be reusing the code, it may be clearer and even easier to use a lambda function instead of the functor. So we're going to go ahead and we're going to create a lambda function here. So I'm just going to delete that, and we'll put that down on a separate line. And I'm going to take the body of this function here. I'm just going to paste it in here, outdent it a little bit, and then I'll put this on another line also just to be clear here. And we're going to use square brackets. So this first part of the lambda function is called the capture part, and this captures the last C, and so we'll declare that right here, and it's capturing it as a reference. I like to space things out like that. You don't have to, obviously. And this function takes a character C as its one argument, and it returns type character. And again, that space is optional, but I like it. And there's our opening bracket, and put our closing bracket down here. So there's our lambda function. So we've taken that function out of the functor, and we're keeping our context right here in line. So our lambda function is actually accessing that. And so let's just compile it and run it, and you can see it work, and then we'll analyze it in a little bit more detail. So there it works just fine. So the lambda function actually has 4 parts. The part in the square brackets is called the capture. And in this case, it's capturing a reference to the last C variable. If you leave this part empty, you cannot use any variables outside the scope of the lambda function itself. Or you may list variables that you want to use, as we've done here, with or without the ampersand. Without the ampersand, they'll be used by value. So a copy of the value will be put in the scope of the lambda function. Or with the ampersand, they're used by reference. And here is a complete chart of what you can put in the square brackets. If you leave it empty, you can use no external variables. You can list variables with and without the ampersand. So in this case, X is captured by value and Y is captured by reference. In our third one, any variable is implicitly captured by reference if used. So you can use any variable you want to outside of your scope within the scope of the enclosing block. Or with an equal sign, you can use any external variable, but they're implicitly captured by value instead of by reference. In our fifth example, we have a bare ampersand and an X. So X is captured by value, and any other variables will be captured by reference. And in our last example, Z is captured by reference, and any other variables will be captured by value implicitly. So those are the things that you could put in that lambda capture declaration. The next part of our lambda definition is the parentheses. That's the argument list, just like with a normal function. And then we have the return type. And this is a new syntax in C++ 11. It's used in a couple of places. But it's now possible to declare the return type of any function using this syntax. If you use it with a regular function, you have to put auto at the left-hand side where you would normally put the type. So for example, up here in int main, I could say int like that, and I could put auto over here, and that would work. So it's just an alternate syntax for expressing a return type, but it works here because there wouldn't otherwise be any place to put the return type. And then the last part of the lambda definition, of course, is the body of the function in curly braces. So lambda functions are convenient for circumstances where you'd otherwise use a functor or a function pointer, but you don't really need to reuse the code. In some circumstances, it can be very clear and readable to define your function in line like this. So now let's delete the working file.